In this episode of FUM0073 machining, we are going to do electronics. This is a continuation of the VFD Modulator project, and this time we are going to solder the components into this printed circuit board. So, first I will show you some of my tools, then we are going to go through surface mounting components and their handling. So, let's go on. Okay, here are some of the tools we are going to need for this operation. First of all, I have a few cutters. These are really small cutters. The cutting edge is on the top of so it's not on the side, but it's on the top. So you can easily cut with these from very tiny places. That's one. And then I have a more general cutter, which is, well, these are, you can maybe see they are well used. Well, these are really good for cutting wire and peeling wire because of the holes in there. Then I have these. I don't know whether I use these today, but these are just ordinary pliers. Well, okay. And then these are really important. This is very, which way my hand should be. You can see these are really sharp. They are needle sharp. These are stainless steel. The brand, if somebody is interested, is Lindström. Sorry. And these are very high quality pliers. And here we also have Lindström. The difference being that these are almost as sharp, but now the material is not stainless steel, it's titanium. Well, these are really good when you want to hold a component in place and solder it. These don't wet by solder. And then I need an ordinary screwdriver, not an ordinary. This has a very small tip, suitable for these guys. It goes there very easily, and I don't damage anything with this. Okay. Then the soldering itself. This is my soldering iron. Well, it's not very big. There is a big power supply out there, but this one, the power for this is 50 watts. And believe me or not, this is the smallest tip I'm going to use today. You can compare that to my fingernail. It's a little bit bent on the edge, and this is no accident. It's the way it should be. And these you can change them. Just put it there, push, and there you are. It's there. Of course, you don't do this when it's hot. Then we have two pieces, a little bit bigger, and then somewhere in between. We are going to use all of these today. Then, of course, we have these ones which we need because the components we are dealing with are really small. What else? Well, I would show you the stand of maybe the bigger camera. Okay, no, you can see it here too. Normally one would use here a wet sponge. I don't like that. It's a mess. My choice is to use either steel wool or, if available, but I haven't seen a lot of that, brass wool would be even better. And yes, this is designed to hold these, and furthermore the brand is Metcal. That's a Rolls-Royce of soldering irons actually. So if you are doing electronics, you can sometimes buy these used, and these bits are very durable. This is actually not nothing like copper. It has carbide tungsten tip here, and all the power is concentrated on a very small area here on the tip. If you look the discoloration of this, you can see that it has never been hot longer than this. So when you hold it with this device, this means that your fingers are quite near the soldering point. Normally when you have a soldering iron, the distance is something like this, and you know it's a different thing having it here or here. So it's easier to pinpoint because now we are talking about half a millimeter accuracy here when we solder this one. Okay, so now this is one tool. And now these are the tools, and then the materials. Furthermore, first of all, this is the tin I'm going to use. It's varoitus, lue käyttöturvallisuustiedote ennen käyttöä. This means that warning, please read the instructions before usage. So this is just ordinary soldering tin. Is it? Yeah. What does it contains? Tin, PT. Wow, platinum. No, and then it contains silver. So this is not doesn't contain any lead. No, it contains, it's PB, not PT, BB. It contains lead. And when it contains lead, it makes it more malleable and easier to solder with. Okay. And then, of course, one of the very important material is this. This is very big. I have made a, normally the picture would be like that size. It's the how you locate the components in here, and then I have the schematic. I like the paper version here. You could look this in your computer screen, but that would be not so nice, and I don't have room here for a computer screen, so paper is better. And okay, so now let's start. The materials. Furthermore, well, these here are my capacitors. Every box contains a little bit different ceramic capacitors. These are really nice. For example, this one contains 1 microfarad ceramic surface mount capacitor, and believe me or not, these boxes, I have the resistors in similar boxes. They replace something like 2 square meters of wall space. Doing with surface mount components, it's nice. Okay, then let's start with soldering the capacitors first. And now, where is my? It's there. Yeah, I already put the correct tip on that, because in this case we don't need the smallest, we want to have the middle one. The capacitors typically go into, maybe I should zoom in. Yeah. So typically capacitors are places like here, here, and here we have two capacitors, and every other one of these is a capacitor, etc. We have some capacitors here. Oh yeah, and one more thing, which I didn't remember about the tools, because this is something we are going to need, is this. This is a hot air gun, but it's a little bit different because you can adjust the temperature. Now it was too low. I put it somewhere around 350 degrees. And it has a very small tip here. And believe me or not, this is 700 watts power. So, ooh, okay. We are going to use it for releasing some of the stresses when we solder these components. And let me start with the capacitors now. First of all, this needs to be clean. Well, it looks like it is clean, but this has been, I have been handling it with my fingers and whatever. So I use some steel wool. I don't use acetone or anything like that because I think they always leave a residue in this surface. And you don't really need to push it. You just wipe a few times like this. And preferably both sides. Because we do some soldering from the back side as well. And then blow away the excess, the residue from this one. Okay, that was steel wool. And now let me zoom in. Like that. I believe it focuses. Yes, it does. And let's see where we are. I need to solder one component in there. Oh yeah. Okay, we will solder one component, do you see it? Yes, in this place and that place we solder a capacitor. Well, the first thing to do here is to put some solder there. Well, and this is my way of doing this. Some guys have a different way of doing this. I do it this way. And now I notice, you know, this thing has this cord, which is, it's not, it's bent. And now I see that the tip is in a wrong orientation. I turn it a little bit so that it is in the correct orientation. I don't want to force it. So now, and I wipe clean the tip in my steel wool sponge. And then I put some solder here. Like that. A little nice bond of solder. You can probably see it now. There it is. And next thing we take, this is now 0.32 microfarads ceramic, these are dusty, capacitor. Yes, I have been in Frankfurt 3 years and these have become rusty. So we are going to use that one. So I'll take these out from here. We need 2 of these. 1 and 2. There you are. We have 2 capacitors. Then we put them on one side, like that. Very gently take, put it in place and then warm it like that. It's there. It doesn't need to be perfect at this moment. And then you put the other there. And believe me, this needs some... oh yeah. I need more magnification. Hopefully I'm not on the way. Now it's it's almost there. Yeah. Okay. You probably see that these are not straight at the moment. It doesn't matter because now we fill in the other side. We solder the other side. And please notice, I'm not putting the solder into the soldering iron. I'm putting it into the component itself. Okay, that one side has enough. Well, I usually do this a lot faster, but now I need to take care of the cameras, and this is not very comfortable for me. And now, what happened here now is that these two capacitors have some stresses on them, and this means that they are if this board gets a lot of temperature changes, gradients, they will actually eventually crack, and therefore the temperature, the coefficients of the dimension, how much they get smaller or bigger when the temperature changes, it's dependent. The dependency is the same with the substrate and the components. And now what I will do, I will warm them up so that the tin melts. And this should, let's see if it is melted. It's almost melted. There you are. They are now straight and stresses are relieved. Well, you can do this by solder paste, but in my case solder paste is it's beyond its best before date. So next I will put all the other capacitors here, and the procedure is exactly the same. Well, I come back when I have done that. Well, this box contains my resistors. Yes, I already did these capacitors here. And you can see there is quite many of them. And one feature of these capacitors is that there is no way you can tell what is the value of each capacitor. There are no markings on them. You might probably predict from the color of the capacitor that okay, this might be that type of capacitor, but from the value you have no idea. So therefore you have to put them there direct from the box. Okay, and now you shouldn't drop these can get damaged. So this is now my resistor box, and as you can see it's quite a selection. And what we need now, I have can calculate it from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 pieces of 8.2 kilo ohm resistors, so they would be under there. So let's take 8 of them out from here. There you have it. There. Okay, now I warm this resistor here. It should actually center itself. Let's see if it does. If it doesn't, I will push it. No, yeah, it didn't. Well, it's there. And then this one, which is way off the center. I like these components to be in proper places. So we need 3 more of those 100 kilo ohm resistors. 3 more. One, 2, 1 more, 3. And a little bit more. Okay, I will do the rest of the resistors off the camera. Okay, now we do some miscellaneous components. And as it happened, I didn't have the needed voltage regulator here. So I needed to get a little bit creative here. So this is a normal TO220 7805 regulator. The original should have been the same thing but in D-pack, but as you will notice, this can be quite easily modified to a D-pack. So, and actually I reserved some space there in the PCB for this modification because I was in Frankfurt when I designed this, so I didn't see my component store, and therefore I didn't know if I had these or not. And now we have to be somewhere there. A little bit more. Yeah, okay. Now it's quite straight. And we can put the other leg as well in place. Actually, I'm quite sure that this component has exactly the same chip inside. It's just different packaging. And now this is now this metal, this soldering iron becomes, you will see how it works. It's really powerful, because now normally if you would solder things like this, you wouldn't be able to do that with a tiny bit like this. But there you are. It's soldered. This one has 50 watts on the tip. And you can see it's there. Properly wet and everything. Yeah, and I need to test this one, whether it broke. Sometimes these don't like the temperature. But let's see. Then we have this capacitor. This is an Oscon, which goes there somewhere. So that's minus. Like that. There you are. But maybe I don't put these through-hole components yet, because it will make this a little bit unstable. Then we have a choke here, which is also quite big. We put it there, and my solder is jamming. This is 0.3 millimeter solder, by the way. So it's very, very, very thin. And now there is the component itself. So now I just put it there, and let's see if no. A little bit more. Yeah. And this is to absorb all possible interference from the VFD before it goes to the regulator. Okay, and a little bit more to this side as well. There you are. And then we have all these little pieces, bits and pieces here, which are really little. And now I will change the tip for this one. There you are. And this is really small. This is like that small. Well, which one to solder first? This one? This is the microcontroller. And now the orientation, please. So if we take it that way, okay, that way. So it means that the one, when this is the same or in the same orientation, so this corner here is number 1. And here we have corner marked number 1. Goes that way. Yeah, and now solder all those little pins there, right? Yes. Let me show a little bit closer for you, if I can. Okay, there we are. So, what I do, I start this from one corner. And I put some solder, put it aside a little bit, and this requires accuracy. Just in one corner, or maybe a little bit too much solder, and then I put the component nearby. Now it's there, and then I see that it's properly aligned. I can bend it a little bit. It must be properly aligned. So this side is okay. This side is okay. This side is not okay. Yeah, it's very. Now it's okay. So now this is also now okay. Okay. You have to check that the pins are well aligned, because if they are not, you will end up, it will be a sorrow, a very unnice day. Then I just come here, warm it, and solder it. There you go. One by one. And you probably should know that this is a totally wrong side for me, so I will turn it around. I just show you how I do it. Now I can see what I'm doing. I didn't see what I was doing. Yeah, the temperature is okay. So let's start from this side. It really did. Okay. This corner here is number 1. Let's put it in place now. It goes this way. So now let's put it into place. And again, check the alignment of the pins. These are really huge if you compare these to the microcontroller. It did. it's there in place now. Then we have something more, but let me have a break here. Okay, now we have this piece of artwork here. So we have two more very small components here. The other one is so-called voltage supervisor. This one goes to there. To that place. And now I just take it like this. Please notice I'm holding it from the sides, and then I place it gently there, and there you go. Well, not exactly in the middle, well, but it will straighten out. There you are. There you are. Then we have this little coil. This is really little. It goes there. It filters the analog voltage for the AD circuit for that one. And this is we put some solder there, and then we put it in place. Let's see. Okay, there. Oh yeah. There you are. Well, the only thing we are now missing are these 4 MOSFETs here. And these are type 2N7002. And I have a few of these here. You probably see. And yeah. Okay. There is probably, yeah, 100 I believe. So same system, put a little ball of solder for everybody, like that. And then we take one from here. That was a little bit funny. Oh. 1, 2, 3, and 4. These are a little bit sensitive to heat, so I cannot actually straighten these out with the heat gun. The housing is some material that melts really easily. So, okay. And now the last one. Let's see if they are quite straight. Okay. Surprisingly straight. Okay, then just solder. Well, yeah. There you are. All 4 of them there. Next will be some radial components, axial components, radial, axial, Oh, well. This for one, this is this Oscon capacitor which goes there. Goes there, like that. Then we have these. They go. Oh, well, this is it. Now we need to change the tip for the soldering iron. Yeah, okay. So we start at this corner, quite simply. So I don't push the solder into the tip. I push it into the piece I'm soldering. Again a ground wire. Yep. Well, one component missing. It's a thing like this. And it has 6 positions. So we need to cut it to 6. That's 4. Oh, there is a 4, 5, 6. There you are. So now this goes into here, like that, and I use, hopefully I can use this one. Yes, I can use this one. So I use these to position it well. So I put this thing into here, a connector. So now it will be in the correct height. If I don't have that, it might be anything. So too low, too high, too whatever. So now just solder it in place. This is actually the programming port. And now I will also solder this side. And this is a little bit tricky sometimes. That was already done, but I will do that. This makes it way more steadier. Okay. There you are. Oh yeah. This is ready for testing. So let's test it. Okay, lessons learned. I tried now to keep this. I probably need to turn this picture upside down. Let's see. Yes, you can see the numbers. I believe so. So what I'm doing here, this is a common ground wire, ground for this and ground for the supply. At the moment the supply is in 0 volts, and we can see that I have a current limiter here, so I can, at this point should measure the input voltage. Well, you can see it rising. Now it's something like, let's put it on 20 volts range. So it's 0.5 volts. Why is it so little? Should be way more. Let's see now. Now it should be, yeah, okay. This is, now it's 2. About 2, yeah, okay. So now we can measure the voltages in different places. We have only 2 volts there. And we should be measuring 2 volts here as well. Yeah, the other side as well. Yeah, on the regulator. Yeah, regulator output should be quite 0. Yeah, there is something. And then we should have on the pin 8. We should have also 2 volts somewhere there. Wait a minute, which one is it? It's that one. Is this wrong way around? Again. No, it's okay. That should be 2 volts at the moment. It is. So now I will probably need to put something under there that you can see it more without the glare, please. Okay, now we first check that this doesn't draw a lot of current. I put this in really in a minimum current limit so that it barely outputs current, and then I put this on somewhere where we should then have 5 volts, and that place is there, quite exactly. And now I will see that, well, you are seeing the meter better than I am. I'm now rising the voltage little by little, or is this the, where is the plus 5 volts? You should have it there. There, okay, let's see now. It should start, oh yeah, now it started rising. And I will see that it will stop to 5 volts. It did. Okay, good. So at least we don't have any shorts there. Then we have here one pin. This is the reset pin, and this should stay low and then suddenly go up. When I rise this about the same voltage it was, it should suddenly go up. I'm now, well, I can show you, now it's still like 0 volts, and then we have here 4 volts. Okay. Now this pin should really jump up quite soon. There you go. So this means that when the voltage reaches the 5 volts, this will release the reset. Okay, it works. And now we should have the same 5 volts here too. Oh, it's not 5 because we didn't have. Okay. Then let's see. What else can we measure here? Now we know that this circuit works. Well, there isn't much you can measure without programming it first. Well, the next test will be if this is responding to programming interface. So, yeah, okay. It doesn't. Well, actually I would like to measure how much current does it consume. We should be on this side. Over. Okay, 8.9 milliamperes. That's quite good, actually. 9 milliamperes. And believe me, the measure of this current is consumed by the regulator. Yeah. So, well, because the supply from the VFD is something limited to 200 milliamperes, so this is more than enough. So this was the how you build these kind of units, and well, in the next episode we will be programming this one, but it will not be looking into monitor. I actually do the program in advance, and then we test that the program. It's program testing more than programming. Okay. See you.